Good morning. I welcome you all for this course on Big Data Analytics. This course consists of 5 units. The first unit is on an introduction to Big Data Analytics. It tells us what is the need for a separate domain of big data and what is the architecture of big data systems. What are all the challenges faced in design of such systems? What are the characteristics of big data? And what is the need for big data? And what are the data analytics life cycle? The second unit discusses about the 4 basic, not only SQL systems, they are key value systems, column family data stores, document data store, and graph data stores. Sample case studies are seen in this second unit. The third unit covers the basics of MapReduce programming and HDFS architecture. The fourth unit discusses on writing the machine learning algorithms using parallelized technique, namely MapReduce technique. And the final unit discusses on text and stream analytics. So this video lecture major consists of 5 modules. In the first module, it comprises of 4 submodules, which consists of basically the need to study big data, what are all the fields that are connected with the field of data science, what are the characteristics of big data, and how it differs from traditional data processing systems. We all know that the current generation data is different from the data which has been analyzed about 10 years back. If you consider the social media data or data from machine logs and transaction data, it consists of different types of data. This different types of data includes data from different sources. It can be of text type, video, images, and so on. The major characteristics of this data is that the size of the data is very large. It is also real-time data, and the data is from multiple heterogeneous sources. So it is highly essential to have a system which can organize this data, manage this data, analyze, disseminate, and perform knowledge discovery operations on such heterogeneous data sets. This requires large-scale computing infrastructure and sophisticated systems for storage. Hence, there is a need for a separate field of big data analytics. We all know that data is the raw material for the current industrial generation, namely 4.0 generation. Let us consider as an example the sales of the cake over the various months of the year, starting from January to December, as shown in this table. Basically, the knowledge pyramid consists of various elements. These elements are discussed with this example. What is data? Data is nothing but the numbers which represent the sales of cakes like 230, 250, and so on. What is information? Information is nothing but some value that is extracted from this data. From the sales of the data, we can see that on analysis, there is more sales in the month of December, January months, there is more sale. So this is called as information. What is knowledge? Connecting this information to external events, such as why such a sales has occurred. It may be connected to a particular community or a festival. That is called as knowledge. Now, what is action? How we can use the knowledge in order to improve on the sales. So what we usually do? We advertise to that particular community so that the sales of the cakes will be increased during the months of November, December, and January. So this is called as a knowledge pyramid. The value of the information grows as we move up the knowledge pyramid from the data, which is basically numbers, extracting value from this data, which is information, connecting this information with external elements or context, which is becomes the knowledge, and finally forming actionable elements forms the wisdom. So the topmost level of the knowledge pyramid is wisdom. This is the business strategy on which all analytics works. Now we will see what are the challenges faced by current generation of data. So data can be of different types. So the three major elements by which the current generation data differ from the older generations of the data is along the volume, velocity, and variety. If you see, the volume of the data or the amount of the data that we are processing or the systems are expected to process has drastically changed. It has moved from terabytes of data to zettabytes of data. The second dimension along which the data has drastically changed is the variety of the data. If you consider the data which is used is of different formats. Initially, it was of text format only. Then we moved on to audio and then the video format. Now the social media format and sensor data is being used. So a variety of data is being used to process the current generation of data. Then last is the velocity of the data. We are processing the data as it comes to us from the real-time sources. Initially, the processing of the data was batch processing of the data based on whatever data is being stored. Now we are processing the data as it becomes available to us from the sensors. So we have moved from batch processing mode to the streaming mode. Based on this, a good definition of what is big data has been provided by Roger Douglas in 2005. A massive volume of structured and unstructured data that is so large that it is difficult to store, analyze, process, share, visualize, and manage the data using traditional database tools and software techniques because of the characteristics of data. So this definition covers a lot of the elements that are suitable for characterization of big data. There have been a number of definitions which have been given by different organizations and industries. Now we will move on to see what is meant by data science and what are all the fields collected with data science. Data science is not something new. Back in 1950 itself, Dahl tried to analyze the smoking pattern by gathering data from a particular city, for example, London. In that, she tried to analyze what has happened and why did that pattern happen, what is likely to happen in the future, what are the actions to be taken based on this analysis of the future, and how we can cause the events to happen. Based on answering these questions only, analytics has been characterized as descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, or cognitive analytics. This has led to different levels of discovery of knowledge. Now, the term data science was coined back in 1960 itself by Peter North, but this became popular after Hayashi in 1996 introduced this term once again in IFCS, saying that the definition of data science. So what is data science? Data science is nothing but basically making sense out of data. This making sense or the discovery process is completely guided by data rather than model in the previous generation. Data science is the extraction of actionable knowledge directly from data through the process of discovery, hypothesis, and analysis of the hypothesis. So, data science is simply making sense out of data. Making sense out of data can be done in an automated fashion or manually. Data science involves both. Data science is primarily concerned with three major domains: mathematics domain, domain expertise, as well as computer science. So, how are these fields related to the field of data science? In mathematics, we have all the optimization, statistics, as well as OR that is needed as preliminary elements to perform analysis on data. Statistics is basically a branch of mathematics that deals with collection, analysis, interpretation, presentation, and organization of a set of data which has been provided to you. The amount of data provided here is less. Data science, as we all know, primarily develops the knowledge from the data. The data is from that particular domain area. The domain can be either healthcare domain, business domain, science domain, law domain, and so on. So the expert of a domain, the use of the domain expert will help us to gather the correct data based upon which the model can be developed. The third major field connected with the field of data science is computer science. How is this related to data science? It is basically consists of developing of the algorithms to analyze the data, frameworks on which these algorithms work, as well as other tools and infrastructure on which the frameworks rest. So this is the basic purpose of computer science. So programming also is a major field in the area of field of computer science, which is highly used in this area of data science. When manually we make use of these mathematical techniques to analyze this data, it becomes statistical research. When we make use of algorithms and other infrastructure and make use of optimization from the field of mathematics to analyze the data, machine learning is used. When frameworks are developed to store, organize, and to process the data, there comes in the field of data processing. Analytics is an intersection of all these fields, which involves processing of the data manually or using machine learning techniques using frameworks. So there comes the area of data analytics. So what are all the fields that are related with data science? Statistics. It is basically a measure of attributes for the sample of the data that has been given. Artificial intelligence is a branch of computer science which helps in solving the tasks using abstract intelligence. Machine learning is a branch of artificial intelligence that aims at designing automated systems that can update and refine themselves by discovering new knowledge. Data mining mainly aims at designing algorithms in the field of computer science to extract insights from the available data. Machine learning and statistics converge on learning of the data. Statistics is estimation based on the sample of data, whereas machine learning makes use of lot of available data in order to develop the models. Data science covers the whole spectrum. It involves manual or automated learning of the characteristics of the data. That is the basic purpose of data science. So how is data science different from machine learning? Basically, Data science is an applied area of machine learning for a particular domain. It can be business, law, science, and so on. So machine learning is a branch of AI, whereas data science in turn uses machine learning for a particular data set or a particular domain. Machine learning aims at developing new models, whereas data science explores the existing models and then tries to characterize the data. Machine learning proves the mathematical properties of models, whereas data science is more empirical in nature. Machine learning is research-based, whereas data science is action-based and it is used by the industry. So these are the major characteristics by which data science and machine learning differ. Machine learning forms the basic foundation which rests over the field of mathematics, and data science uses machine learning for domain data. So how is data analytics different from machine learning? Data analytics tries to make use of the data to draw insights and to improve on the business. As we have already seen previously, data analytics can be classified into 5 different types. The first one is descriptive analytics, which tries to analyze what is given, what is the data present, and tries out and gets some statistical properties of the data. Diagnostic analytics, which basically identifies what is the reason for those statistical properties. And predictive analytics tries to discover new knowledge from existing knowledge. Prescriptive analytics tries to identify why such a trend occurs. And cognitive analytics tries to identify based on actuators and sensors, it causes the actions to occur based on the future discovery. So these are the 5 areas of data analytics. Now we will see that in detail with the same example, which we have seen on the sales of the cakes. The first one is descriptive analytics. It just tells us what has happened. It just identifies what are all the data that is present and extracts some statistical properties from the data. For example, it may say that the maximum sales has occurred in the month of December. So that is meant by descriptive analytics. Or what is the average sales throughout the year? The second type of analytics is diagnostic analytics. It tells to identify using context knowledge why such a thing has happened. For example, why there is maximum sales in the month of December. It may be connected to a particular festival like Christmas, and hence there is more sales of cakes. So that is what is meant by diagnostic analytics. Next is predictive analytics. It tries to identify the future trend based on what data is available. Suppose there is a sales of cakes which is known up till the month of September, then predicting the sales of the cake in the month of October is called as predictive analytics. It tries to identify the future trend. Now, what is meant by prescriptive analytics? It tries to identify, to make that sales, what is the action to be taken. For example, if you want to improve the sales in the month of October, should we offer any discounts? So what is the action to be taken is identified by the prescriptive analytics. The last type of analytics is cognitive analytics. Cognitive analytics is nothing but causing the actions taken by prescriptive analytics to occur by making use of the actuators. Here the action taken is whether we have to offer discounts or whether we have to advertise it to a particular segment of customers. Therefore, to take the actions, emails are sent to the customer segments. So this is how the 5 types of analytics occurs and how they differ from one another. So this gives the complexity of the different types of analytics. Descriptive analytics basically gives a hindsight on what data is present. Diagnostic analytics tells us why this has occurred, so it is called as insight. Predictive analytics tries to identify something in the future, so it is foresight. Prescriptive analytics tries to identify something or the context connected with predictive analytics. Therefore, it is called as contextual in nature. And finally, the cognitive analytics causes an action to occur. So descriptive as well as diagnostic analytics are concerned with the data and information portion of the knowledge pyramid, whereas predictive, prescriptive, and cognitive analytics are concerned with the knowledge and wisdom portion of the knowledge pyramid. The value of the data increases from the descriptive to the cognitive analytics, from the data to the wisdom. Thank you very much for listening to this module. The next module will be on characteristics of big data. Thank you very much.